Solving any force problem first involves drawing the picture, and so a free body diagram is going to be helpful every single time. Okay, and so that was the first problem here. It says a 5 kilogram crate is pushed, causing it to move at 7 meters per second along the horizontal floor. If you have a velocity, don't draw that as a vector attached to the box. The vectors attached to the box just show forces. So the 7 meters per second I'm going to put right here. I picked that direction. It wasn't told in the problem. Doesn't matter. Okay, 7 meters per second, and it's moving. The box slides to a stop after traveling 3.2 meters. Draw a free body diagram of the box as it is sliding across the floor. Okay, it's now in motion. We're not worried about the force that caused it to move. We're worried about the forces that are acting on it as it's moving. Of course, the first one we always tend to draw is gravity. Gravity pulls straight down, and then the normal force pushes against that. Okay, so there's the normal force, there's gravity. This box is in motion. That means kinetic friction opposes the motion. Since I drew the motion is to the right, that means kinetic friction will be to the left, Fk. Okay? Those are the only forces acting on it. There is no force forward. Forces are not required to keep an object in motion. Forces are required to change an object's motion. Forces cause acceleration. Okay, this is determine the normal force. Well, since the net force in the y direction is equal to 0, I know that because the acceleration is 0, I can say that the force of gravity is exactly equal and opposite to the normal force, which is then mg, and so this is just 5 times 9.8, and that's 49 newtons. And I think most everybody did that okay. Which frictional force causes the box to stop? Well, it's in motion, and the thing that's causing it to stop is right here, Fk. That means kinetic friction. Kinetic friction is opposing the sliding motion of the box. Okay, the box is in motion. Determine the acceleration of the crate. Okay, so back up to that picture. Which way is the crate accelerating? It's moving to the right, but it's accelerating to the left. The acceleration is this way because that's the only unbalanced force that acts. So I can say the net force, according to Newton's second law, is equal to mass times acceleration, but the net force is the frictional force. So the frictional force equals mass times acceleration. Okay? Well, that means if we know the acceleration, we can find the frictional force. But we have enough information to do that. An initial velocity of the crate, is 7 meters per second. The final velocity, it comes to a stop, so that's 0. It said it took a distance of 3.2 meters to do that. Okay? So change in position is 3.2, and I need the acceleration because I know the mass. So final velocity squared equals initial velocity squared plus twice the acceleration times the change in position. But then 0 equals 7 squared plus 2 times a times 3.2. Okay? And so I get 0 equals 49 minus 6.4 times a. So that's plus. Okay, sorry. So negative 49 equals 6.4a. I divide and I get an acceleration of about 7.6 meters per second, except it's a negative 7.6. And the reason it's negative is because that acceleration is to the left and my velocity was to the right. They're in opposite directions. So if my 7 meters per second was positive, my acceleration needs to be negative. Okay? Remember that. Acceleration is a vector. You can't just drop a negative sign because it scares you. Determine the frictional force acting on the cart. Okay? Well, it turns out I didn't need this net force up here because I didn't have enough information. I didn't know the frictional force, I didn't know the kinetic frictional coefficient, but I knew all this information. However, now that I know the acceleration, that equation still works. Fk equals ma. Well, this is now equal to 5 times negative 7.6, which equals about negative 38 newtons. Okay? And it's a negative 38 newtons because it's acting to the left, and to the left is negative in this problem. Determine the coefficient of friction between the box and the floor. Well, okay, the coefficient of friction only appears in one equation, and that equation is the kinetic frictional force equals the normal force times the coefficient of friction. okay, which means if I have the frictional force and the normal force, I can calculate the coefficient of friction. So Fk divided by Fn equals the coefficient of friction, and I have all this information. 38 divided by 49 is about 0.76. There are no units, it's just a relationship between two forces. Okay, so you're good to go there. The biggest problem I saw on these problems were right here, where this negative sign got dropped, and right here. A lot of people just copied down this acceleration. If forces are not accelerations, okay, forces cause accelerations, they are not accelerations. Alright, let's go to the back of this quiz. The coefficient of static friction of a tire on wet pavement is 0.7. Okay, it's static friction because the tire is rolling across the pavement, and so this point and this point, they're in contact, but they're not sliding. Okay, if it starts to slide, then it'll be kinetic friction. So what is the maximum force the brakes of a 1,220 kilogram car can apply on a horizontal surface before the tires start to slide? Okay, all we're looking for then is how big can this static frictional force be? Well, Fs is equal to the normal force times the coefficient of static friction, right? Because if I draw this picture, here's my car driving down the road, okay, and gravity's this way, normal force is this way, and I'm going to assume it's moving this way so I can have my frictional force be backwards. And it's static friction because we're not going to lock up the tires. So the maximum force the brakes of a 1,220 kilogram car can apply, well, that's just equal to the normal force, which is going to be mg, since this is horizontal, times the coefficient of friction, 0.7. And so I'm going to take 1,220 times 9.8 times 0.7, and I'll have my answer. 8,369.2 newtons. Okay? If we go with more force than that, the tires are going to lock up because there's not enough friction to keep the tires from sliding, and then the car will skid instead of come to a nice stop. What is the acceleration of the car if the force above is applied? Well, Newton's second laws is net force equals mass times acceleration, and so you're basically going to take this net force that you just calculated, because it's the frictional force, it's the only one acting in the x direction, so 8,369.2 equals m, the mass of the car, 1,220, times a, and you'll do the division, okay, 1220, which equals 6.86 meters per second per second. Now, I had several people just say A equals mu s times g. This works, but only on a horizontal surface. Only on a horizontal surface. Because the reason this works is because mg is the normal force and ma is force. And so the masses cancel. But g is not necessarily going to be there on an incline. It won't be exactly opposite the normal force. So this is only on a horizontal thing. So I would not recommend that you get in the habit of doing that. How long would it take the car to stop if it was traveling at 30 meters per second when the brakes were applied? Okay, so final velocity, it's going to stop. Initial velocity is 30 meters per second. Acceleration is what I want to know. Nope, acceleration is what I just calculated. Okay, 6.86. Now, here's the thing. When I did B, I didn't pay attention to direction. I just got the, or when I did A, I guess I didn't pay attention to the direction. But if to the left is positive, then I'm okay. If to the right is positive, then that should be a negative force. Okay? And since it's traveling at 30 meters per second, the brakes are applied. I know the acceleration is opposite that, so I'm going to have my acceleration be negative 6.86. And then all I got to do is find the time, and we'll be good to go. And we have an equation for this. V equals V naught plus AT. And so 0 equals 30 plus negative 6.86 times time. So 30 divided by 6.86, and time is about 4.7 seconds, give or take. Okay, so that one was fairly straightforward. The last problem on here, the dreaded incline problem, right? It says draw a free body diagram showing all the forces of this skier as he descends a slope. Okay, so first I have my slope. It's inclined at 30 degrees. Here's my skier. Yep, my skier looks like a box. Okay, gravity does pull straight down. That's the only force that's oriented not parallel or perpendicular to the incline. Okay, gravity always pulls down. The normal force does not push against gravity. The normal force pushes perpendicular to the surface. The normal force actually goes that way. Okay, friction acts, right? It tells you there's a frictional coefficient, so friction is between it. Well, the skier is descending a slope. Friction acts against that, so the kinetic frictional force is up the slope, and it's kinetic friction because they are moving. Okay, so I've got these forces that I have to deal with. Okay, generally speaking, we orient our reference frame so that x is down the incline and y is perpendicular to the incline, because that way there is no acceleration in y. All the acceleration is in x. Okay, and so that means I need to actually find the components of gravity that are in x and that are in y. This is always perpendicular because we're finding the x and y parts of this force, and those are the orthogonal coordinate systems. Okay, so normal force and FGY are going to be equal because the acceleration in y is 0. And then this is FGX down here, and you have to find that. Okay, because to determine the acceleration of the skier, we're going to use Newton's second law, which is net force equals mass times acceleration. The skier is accelerating in x, so I don't have to worry about these y directions. Okay, so all I'm going to deal with is the net force in x. Well, the net force in x is FGX minus the kinetic frictional force, and that's going to equal mass times acceleration. Okay, I subtracted because they're in opposite directions, right? Gravity's pulling them down the incline, friction is acting up the incline. Well, FGX is this side of this triangle. That's the opposite side of this right triangle when we know the angle here. So that's mg, force due to gravity, times the sine of the angle, which is 30 degrees, gives me how big mgx is. I have to subtract off of that the frictional force. But the frictional force is equal to the normal force times the coefficient of kinetic friction. The normal force is not mg in this case. It's the y component of gravity because the normal force is opposing the y component of gravity. So that's the adjacent side in this triangle. So it's going to be mg for the normal force times the cosine of the angle. So we're only dealing with the y component of that times the coefficient of kinetic friction, which is 0.1, needs to equal ma. That's Newton's second law. Mass cancels because mass is in everything. You'll notice gravity is not. G's in this term and in this term, but G is not over here, so I can't just cross out G. So now I have 9.8 times the sine of 30 minus 9.8 times the cosine of 30 times 0.1 equals A. And when you work that all out, you're not going to come up with 0.3, but rather a number that's closer to 3.8. Okay, let me do the math real quick. Sine 30, sine of 30 times 9.8 is 4.9 minus the cosine of 30 times 9.8 times 0.1 for the kinetic frictional coefficient. Well, that was interesting. 30 cosine times 9.8 times 0.1 is 0.848. So minus 0.848 equals A. Okay, and so then I do that subtraction, and I get an acceleration of around negative 4.05 meters per second. Okay, or not negative. That's positive. Okay, positive 4.5 meters per second. Okay, so the trick to this problem is you have to remember it's inclined, and when it's inclined, the normal force acts not against gravity, but perpendicular to the surface.